Yeah. So 9 students have joined. That's good. So from today, I'll be taking your class. Okay. So today is it's just like a simple session, numerical session. Okay. So because I just want to know how much the things you people have learned till now. So welcome to today's class. Maybe you people know me. Okay. So from tomorrow we'll start the theoretical part, dielectrics and all. So welcome to today's class, JNV Mandia students, JNV Kulbarga, Trishna, Tejaswani, Swastik, Sneha and all. Okay. Ananya and all. Okay. So let us start it. And yeah. Welcome to today's class. So let me record to the cloud. Boom. So it is started. Let me see if there is any data issue here. No, everything is fine. Everything is fine. Yes, this is also clear. Good. Okay, students. So let us start a class. I hope it's properly visible on the YouTube also there. Cool. Okay. So today we'll be having a numerical session. Let me tell you this thing. This session will be completely numerical. First of all, let me launch a technical poll, okay, so that I can get to know if everything is clear. The two things must be clear to you. Key, I must be audible to you properly. Next is this key. Screen must be properly visible to you. Okay. Reply in the chat box, everyone. Or you just participate in this technical checkup. Just participate in the technical checkup so that we can proceed fast towards the class. Okay. So how many students have joined? 13 students have joined. What about the other students? What they are doing? Okay, so I'm ending the poll now. Time is up. We have only less time, less minutes remaining. Okay. All of you must participate. Okay. Okay, so I think you have participated in the poll and everything is okay. So there is no any technical issue. If you still feel any issues in between the class, please reply me in the chat box. Okay. So I'm ending this poll. So this is the first question. So it's like prerequisite for before starting the next topic, that is dielectrics. Okay. So these are, you can call it as like prerequisite, or you can call it as like revision session for the numericals. We'll revise the session. We'll revise the theory topics along with the numericals. I mean, theory will be revised by its application via numericals. Okay, so it's a complete numerical session. So first question in front of you, we'll try to solve at least 8 to 9 questions because the questions level is above average here. Okay, so first question on your screen here. Try to solve it. I'm giving you a few minutes for this. Try to solve it yourself. Question says what you are doing this. Yeah, you are not allowed to do annotations. So I'll remove you. Sagar is your name. I'm going to remove you now. So you're not able to join the next classes, any of the classes. Remove this fast, otherwise I will remove you. Yeah. So let me see here. Annotations. There's no any annotation kind of option. Hide names for annoters. Yeah. So your annotations are disabled now. Okay. No issues. No issues. Okay. So the capacitance C. So the question is this: the capacitance C for an isolated conducting sphere. So suppose you are having an isolated conducting sphere. Okay. and this is having the radius A. So its capacitance is given by this value, that is 4 pi epsilon naught into A, as you all know. And Sham sir have taught you about this. He might have taught you about the capacitance value. Okay. Is it clear? Reply up to here. Next is this. Now, if the sphere is enclosed with an earthed concentric sphere, the ratio of the radii of the spheres being this, then the capacitance of such a sphere will be increased by what factor? Okay. So what they are telling us here is this. Suppose if I enclose this inner sphere in this big sphere, which is concentric and earthed, okay, and the ratio of the radii is given as n by n minus 1. So by how much factor the capacitance is increased of such a sphere? This is the question, students. I hope it's very much clear to you. If it's clear, please reply its answer. You're having 4 options in front of you. Yeah. The session will not be fast. It will be very slow. 4 options, answer me. What do you think? How will approach this question? Little bit I'm giving you the hint for the solution, because this is the question which you must complete. Suppose you're having an inner sphere having the radius A, and then you're having a bigger sphere which is having the radius is equals to B. Okay? And they say here ki B upon A is given by n upon n minus 1. Okay? And then they're asking us if actually what they're asking, this question can be modified and been asked like this: the final capacitance is how many times the initial capacitance. Okay, you can think like this. Try to solve this question. Your time starts now. Then the capacitance of such a sphere will be increased by what factor? What is the factor by which this C1 capacitor will increase if we enclose this in a concentric sphere of say radius B? Okay? Are you able to solve this? Yes or no? What about all the students? Abhi, Ananya, and all the students? You must solve this, okay? I'll give you just 1 minute for this. Your time has already started. Then I will solve it. Are you able to understand the question? Please, anybody reply in the chat box. Any one of you. Abhi, Ananya, Gaya, Nageshwari, anybody. Okay. Sagar, anybody. So you must reply in the chat box. Okay, what is the answer? Then I'll provide the solution. Okay. Reply in the chat box. You are having 1 minute left, then I'll give you the solution. Okay. Yes. Okay, I'll provide you the solution. So I think you people don't know about these questions. Maybe you haven't practiced a lot of questions. So I'll be directly solving the questions now. Okay. Yeah. So let us approach towards the solution. So think like this. This is an inner sphere which is having the radius. How much? Today is just a numerical session, so we'll be slow. Which is having the inner radius is equals to A. And this is the outer sphere which is having the radius which is equals to B. Okay. And if we see the inner sphere is having the capacitance is equals to how much? Inner sphere is having the capacitance is equals to, we know this thing by the formula. It's already given in the numerical. This is equals to 4 pi epsilon naught A. Okay. So this is inner capacitance of this capacitor having the radius A. And this is the outer capacitor having spherical capacitor which is having the radius B. So if anybody want to say how much will be the capacitance of this outer capacitor having the radius B, this will be C final is equals to kitna hai? It is 4 pi epsilon naught and then AB. You know this thing. Dekho, C final kya hoga? When you will enclose this in a bigger sphere of which is earthed basically, we know concentric spherical conductors ka net capacitance is given by this formula. You have already learned this in earlier previous classes. Okay. ठीक है? Yeah. So we'll say now we got a C final as what? We have C final as 4 pi epsilon naught AB upon B minus A. Abhi isme we'll do some modifications so that it matches with the MCQ. These are all branded questions. These are 5-star questions, students. ऐसे वैसे questions नहीं है ये. Just whatever the things which has been taught to you in the class, keep those things in mind. Because this question is say less level question will be asked in the NEET papers or some test papers from the Avanti, okay, or maybe equal to it. So इसमें कुछ modification करना है. So what we'll do is this. I'll take B common from this. So this is 4 pi epsilon naught AB. If you'll take B common, what will come in the bracket? Bracket में आएगा 1 minus A by B. ठीक है? अभी देखो B by A is n upon n minus 1. So what will be, this is like a game. What will be A by B? क्या आएगा? A by B will come to be, I'm writing it again, C 4 pi epsilon naught A. ठीक? B I took common, so in the bracket it was 1 minus A by B. ठीक है? So this is 4 pi epsilon naught A. So this is B. 1 minus A by B. So we have A by B value as this much. It's very much simplified because B by A is already given in the question. ठीक? अभी if you check it, इसको जब solve करेंगे, just solve this thing. What will come? What do you think? And again, we have A upon B value here. So इसको put कर दो. 4 pi epsilon naught A upon B comes out to be n minus 1 upon n, and the denominator में है 1 minus n minus 1 upon n. ठीक है? So we are having the net value now, it is equals to n minus 1 upon n. इसको करेंगे तो it will come out to be n minus n will cancel, so this will be 1 upon n. So this will get cancelled with this. So net answer which we are getting is this, students, ki 4 pi epsilon naught A, ठीक है, into n. This is the C net value, and we know here that 4 pi epsilon naught A is nothing but C1 value. So we get कि C net is equals to n times C1. Remember this. इसमें कुछ A का factor है, check it out. It may be missing it. Okay. I hope it's clear. Yes. So this will be the answer, students. We'll say C net value comes out to be n times. So answer is A. This question, my students, I hope it's cleared. If you're still facing any doubt, please reply in the chat box. This question is clear, students. If you're still facing any doubt, please reply. Abhi says, not clear, sir. So what's the issue in this question? Reply me in the chat box. Abhi, what's the issue in this question? Why are you not able to understand this? Very simple, na? देखो inner capacitance दे रखा है. Anybody else? Please reply in the chat box. Who understood this question? Gives a thumbs up or like reply in the chat box. Yes, it's understood. Proceed for the next question. देखो very easy question है. Yeah, very good. So one of the students thumbs up. That's good. But I will explain it again for you. Okay. So you understand like this. I'll be solving it here. Suppose you're having an inner sphere. देखो spherical जो capacitor होता है उसका capacitance is given as, इसका radius is r, so it will be given as 4 pi epsilon naught r, and there is a concentric spherical conductor with this. So net concentric spherical capacitor का capacitance is given by 4 pi r1 r2 r1 minus r2. So I've used these formulas and find the answer. Simple, very much simple it is. Okay. I hope abhi it's cleared. I hope it's cleared. ऐसे तो time ही नहीं. We'll not able to solve just one question also. Proceed towards the next. चलो ये question try to solve it. 3 long concentric conducting cylindrical shells. Sagar, very good. 3 long concentric conducting cylindrical shells have radius r, 2r, and 2 root 2r. So if we see cylinders, मतलब एक cylinder, दो cylinder, तीसरा cylinder, मतलब 3 cylinders. Let me make a proper diagram here. So we are having 3 cylinders here, concentric. I'm just showing here the side surface. Okay. So inner wala is having the radius r. This wala is having the radius 2r. This wala is having the radius 2 root 2r. Okay. Inner and outer shells are connected to each other. This and this are connected to each other. The capacitance across middle and inner shells per unit length will be how much? This is the question, students. The capacitance across the middle and inner shell. मतलब ये inner shell है of the radius r and 2r radius. So capacitance between r and 2r radius of wala shell में capacitance is how much? What is the capacitance between the cylinder of radius r and 2r? कितना capacitance होगा? This is a question. Try to solve it. Okay. So I'll be providing the solution here. See here carefully. Today is just a numerical session, so I will proceed continuously. Okay. So first of all, you must know that suppose you are given a concentric cylinders. Concentric matlab two concentric cylinders like this. So these are two concentric cylinders. Okay, I'm drawing it properly. These are two concentric cylinders. अब capacitance अगर इसका देखना है तो you have studied in the class the formula is C 2 pi epsilon naught ln if outer radius is B and inner radius is A, so this gives you the value ln B by A. First of all, you must remember this formula always for concentric cylinder. Okay. Now in this question they're asking to find the capacitance between the inner matlab R and the capacitance across the middle and the inner shells. Inner shell is R and the middle shell is 2R. So just find the values. So you can put like this. You must put here. This is equals to as okay. We are having how many inner cylinders? We are having the inner cylinders as this is R. This is 2R. This is 2 root 2R. So outer one is 2 root 2R. First of all, let us find the net capacitance here. Okay. So net will come out to be how much? Use the formula 2 pi epsilon naught. First of all, with respect to the inner and the inner and the middle one. Okay. So ln 2r is the middle one and inner one. Okay. We need what we need the net. So this is what 2 pi epsilon naught ln 2 root 2 upon 2r into r. ये भी हो गया. ठीक है. अब इसमें से common लो this value. So this comes out to be 6 pi epsilon naught by ln 2. And this is your final answer. अब now you people have to remember the formula. This इसमें कुछ नहीं कर सकते. Okay, you have to go back home and take the notes, derive it, and apply here. Okay, so this is the answer. B is the answer. If you understood, it's good. If you're not able to understood, then you have to see it yourself. Okay. I mean, because this is just a numerical session, so tomorrow I will start with the dielectrics and some more. Whatever the doubts you are having. So one thing you can do is this, students. You must reply on this number. This is my personal number. So what are the doubts which you are facing in today's session, or the topic which you want to include from the capacitor chapter in tomorrow's class? You just reply me here, give a text here. Okay, so I'll see that and I will include all those doubts in tomorrow's class with the fresh topic, that is dielectrics. Okay, I hope it's clear. This is a number. I'm also sharing this in chat box so people will not ask it again and again. So this I'm sharing to everyone. I hope it's clear. Let us proceed next. Fourth question, students. It is one of the easiest question here. It says, what does it say? It says a capacitor of capacitance C is charged to a potential difference V. Okay, so we are having a capacitor. It is charged to a potential difference V. Okay, so from a cell and then disconnected from it. So it was connected by a cell and then it was disconnected. Okay, a charge plus q is now given to its positive plate. So iski positive plate pe a charge plus q from external sense, external by external agent, it's given to it. The potential difference across the capacitor kitna ho jayega? They're asking. Very simple question, students. I hope you are able to understand it properly. Hai na? So anybody want to try this? 1 minute for you. I'm giving you 1 minute for this. Try it out. Read the question yourself and try it out. Otherwise, it will be like spoon feeding. It will not work. It will never work. Okay. It will never work. Try to solve it yourself. Students, try to solve it yourself. Okay. Or reply in the chat box to proceed. Okay, I'm solving it. See. So capacitor, you know, capacitor consists of what? It consists of a positive and a negative plate. So initially it has been charged with the potential difference plus minus V. Okay. An external, so it will be having the charges initially as CV and this minus CV. Okay. Now external, from the external agent, it's been provided with the charge Q here. So what's going to happen is this, there will be an equal distribution of the charges in this sense. That is, this is the initial condition. If I'm drawing it here, this is the initial condition. This is what, this is initial condition. So the final condition will be this. This is CV charge initially here. I mean, Q is equals to CV. So the charge distribution will be like this. Q will go divide itself into half of its time. You must know this thing always. Okay. Q by 2, and this will be CV plus Q by 2. This will be minus CV minus Q by 2, and this will be Q by 2. Now, if the doubt arises why this is like this, because if this is Q by 2, remaining will be, I mean, this will get add up with this, and also this will be CV plus Q by 2. And if this is minus CV, so internally it will be what? Minus CV minus Q by 2, because we know internal capacitor plates hota hai, uspe charges kaisa hota hai? Nature of the charges is opposite in nature and the magnitude is same here. Okay? Let us proceed next. So answer according to this will be, come out to be net potential difference they're asking. So this will add up with this, that the net potential difference comes out to be V upon Q by 2C. If this is the net charge, so net potential is what? We know net charge is equals to capacitance into potential difference. So we need the net potential difference. Just divide this with the C, you'll get the answer. V plus Q by 2C is the answer. If you got it, it's okay. Otherwise, you have to check it yourself in the PDF and the YouTube video. Okay. Otherwise, it will be spoon feeding again. And we have to solve many questions. Tomorrow, dielectrics with the doubts, as the doubts which you will send on the mobile number. Okay. So 6th number question, students now. So this is also a very easy question. You have solved a majority of questions I have seen in the YouTube video. Majority of the students have solved majority of the questions from this. So let us see this here. Hold on 1 second. Let me see if there is any technical issue here. Hello. Yeah, it's audible. No, 2 students left. No, that's why. Okay, now the question says this. A capacitor of capacitance C is initially charged to a potential difference of V volt. So suppose you are having a capacitor of capacitance C. So this is suppose a capacitor that is having a capacitance C. Okay? It is initially charged to a potential difference V volt. So initially the capacitor is charged with the V volts, and now it is connected to again with a 2-volt battery. So it's like bonus to this capacitor. Capacitor is gaining bonus. Why? Because initially it is already charged with this potential difference, so it will retain its charge. I mean, it will retain the charge under this potential difference. Finally, it is connected with a 2-volt battery again. Okay, with a positive polarity, but the polarity is the opposite. It's like minus plus. So they're asking the ratio of the heat generated to the final energy stored in the capacitor will be how much. Of course, wherever there is the current passing in the wire or capacitor, the charges are stored. They are variable in the capacitor plates. There will be always heat generated here. So there will be what? There will be heat generated like this. Okay. So they are asking here in this question, what will be ratio of the heat generated to the final energy stored in the capacitor. Ratio of the heat generated to the final energy which is stored in the capacitor here. Okay? So this is a question. So I'll approach this. I'll solve this question. Okay. I will initiate here because I think it will not be able to. You will maybe not be able to solve this question because nobody has solved here. Okay. So let us move. Tomorrow will be dielectrics, pure numerical. Today there was a sudden numerical session. Okay. Tomorrow we'll start with the theoretical session. This one, dielectrics. Let's go for the next. Sorry, this question is obviously solved me, Juana. So first we'll solve this. So if you see the initial conditions here, this is a plate which is having the CV charge because it is charged with some charge Q, and this charge Q is CV because the potential difference across the plate is plus V. Okay. And this is minus CV, and this, if I connect like this is the battery here. This is the initial condition. This is what? This is initial picture, by the way. Yes. And finally they say कि एक opposite polarity का battery. This battery is having the fine polarity. I mean, whatever in general we use in the circuits. But this battery, if you see the polarity, if I talk about this, or for this battery, it is opposite. It's minus plus, and also the magnitude is twice of that. So now there will be change on the plate. There will be change on the charges which are on the plates of this capacitor in this picture. Okay, so this will be CV, and this will be twice of CV here. And this, if you see here, this comes out to be what? The current which will be passing, remember always, it will be 3 CV. Okay? This can be easily understood from the picture itself. देखो ये Q क्या है? This is Q only, no? I mean the charges which are passing is 3 CV here. Net charge, okay? So heat generated, you need to find heat generated is like energy here. So if you need to find the heat generated here, you'll say like this: heat generated will come out to be net heat. That is how much it will be? It will be 6 CV square minus the initial conditions from this capacitor. Okay, this is half. See, I'm assuming you know all these questions how to solve it. That's why I'm solving it fast. This question got tomorrow. We'll see with the theory again. Okay. So finally, somehow you'll solve it. You'll get the answer as 2.25. Let's proceed for the next. If you didn't understood, don't worry. Be happy. Tomorrow we'll see the theory. Today is just a sudden numerical session. Okay. Next. Now this question is interesting, students. All of us can solve this question easily. Yeah. But before this, I need to show you some other questions. Let's hold on. Not this, not this. Yeah, try to solve this question. This question is more important than all the previous questions which were on the slide. So this question will take time for you to solve, but you have to understand this. This came in the JEE Advanced, and this question is also, you can see the part of this question in IRIDA. I mean, same kind of question is also in IE IRIDA. This is a very advanced level physics numerical book. Okay. So this question consists of the fusion of two concepts, one from the classical mechanics, your 11th syllabus, that is spring force, plus from the 12th syllabus, that is capacitor. So both of these concepts are fused together, and then this question, that is the 10-number question, is basically made. Okay. So let us now understand the depth of this question. What is the depth of this question? Let us go through that. So it says plate A of parallel air-filled capacitor. So this you can see, this is a parallel plate capacitor. What you call it as? Because you have studied these things in the theory itself. This is known as parallel plate capacitor. Parallel plate capacitor. Tomorrow, don't forget to come, because tomorrow we'll be studying the actual session. Today is just knowledge-based session. I mean, it's just a quiz session here. I just want to know your knowledge. Prerequisite session it is. Okay. Tomorrow we'll start with the actual session, the theoretical session. So this is a capacitor. These are the parallel plates of the capacitor. We know this kind of capacitor is known as parallel plate capacitor. Okay, I hope you understood this thing. Now they say it's connected to a spring having the force constant K. So in front of you here is a spring which is having some spring constant, also known as, if this spring is the system complete, including the spring and the capacitor, is been treated as like SHM, simple harmonic motion. So we can say that it is like a kaisa motion hai. This K will be now known with some different name. The name is what? It is force constant. Okay, वैसे तो उसको spring constant कहते हैं. Otherwise we say it like spring constant. Now, so let us approach for the go for the question. And plate B is fixed. So this plate is fixed here. Okay. If charge plus Q is placed on the plate A, suppose if I place a charge plus Q on this plate and charge minus Q on the plate B, and suppose if I place charge minus Q on this plate, that is negative plate here. Okay. Then find out the extension in the spring in equilibrium. I mean, when the equilibrium condition will be achieved, you have to find the extension in the spring, assuming the area of the plate to be constant. So this is the question. And why there will be the extension in the spring? There will be oscillation kind of thing initially. But finally, when the spring is in equilibrium, there will be some extension here. So they're asking you here how much that extension will be. Pehle, can anybody tell why the extension in the spring will be? Why the spring will get extend from the natural length position? Anybody can answer? Who have studied the previous lectures from the class session, that the teacher who have taught you, who have seen the PPTs, the PDFs, all those things. If you have gone through that, can you answer this? Okay, let me tell you what's the reason, by the way, due to which this, today is just numerical session, okay? Or the reason due to which this spring is extended. So what will actually happen is this: when you connect a spring with a capacitor, which is basically, yeah, one student have replied, very good. Manthan says electric field, excellent Manthan. So this shows that your concepts are really clear. You can crack J easily if you go with this approach for the physics plus maths and chemistry, as per the teachers are training you there. Okay. So the charges on the plate are plus Q charge, and charges on the plate B is minus Q charge. Okay. So what's going to happen is this: there will be the electric field in this, and there will be a force between the plates. Remember, so there will be a force between the plates because these are opposite nature, attraction kind of. Okay, there will be a force. So this force will provide its effect here at this point, So this effect will travel up to this point. So due to which there will be extension in the spring. Okay, this is the concept that why there will be extension in the spring. The concept that why there will be extension in the spring is this. Now let us apply this concept as an application and solve this numerical completely. Okay. So remember, when there are two plates of the capacitor and they are charged like this and they are making its own particular specific system. Okay. So force between the in such a condition, you must remember this formula. So through these numerical sessions, you'll be able to know that if you don't practice the questions, you just go through the theories, whatever is taught in the class in the earlier days. And if you don't practice the questions randomly from the Avanti module, then it will not work. Okay. So are you provided the Avanti module? I'll give you here in the session only if you are not provided. Avanti module PDF mila hai na everybody? Okay, fine. So force between the plates, if you see here, क्या देखोगे? That force between the plates. Always remember this thing that if you have studied also, if you haven't studied, it is always given by this formula, that is Q square by 2A epsilon naught. This is the formula for a capacitor plate having the charge of opposite nature. Of course, it's sure that these are capacitor plates. And force between them is this attractive. Unlike charges, attract each other. Like charges repel each other, whether positive, positive or negative, negative. Now, if this is the force between the capacitor plate, this is a force magnitude between the capacitor plate. So this can be applied for a spring force. So what is my next step? You already knew it. You already know it, okay? But I'll be applying that force magnitude as a spring force. So this is spring constant, or you can call it as like a force constant. So this can be compared with this, that is Q square upon 2A epsilon naught K. K will come down. So X here comes out to be Q square by 2A epsilon naught into K. This is the extension in the spring, student. I hope it's clear. I hope it's clear, students. So C is the answer, student. C will be your answer, okay? Yeah. Is this question clear, 100% crystal clear or not? Because this was important question. That's why I've given, none of the question I've given this kind of importance, fusion, and taught you about all these things. This question is based on J advanced level, I tell you, because it includes the fusion of the various concepts. So in advanced, the question is not asked to you straightforward. The concepts are fused and they are asked. This is J advanced level question. Okay? I hope it's clear. Please reply in the chat box. So the answer is this. K comes out to be, sorry, extension comes out to be Q square by 2K epsilon naught A. Please reply in the chat box if this thing is clear so we can proceed next. Very good. So next of the questions, if you see, students, this is a very interesting question which is on your screen, okay? This you can mark it as a green star. Please don't make unnecessary noise in the class. I'll send you out. Okay, so I need to clear this. Who is this person? Pratik and Ryan. Yeah. So this is a question. I think this is the last session, last question of this session today's. Okay, then I'll launch the poll. Fine. So be very much focused for this. Got it? Yes. So they say here that if the charge, be focused here, students. They say here this, if the charge on the left plane, left plane of the 5 microfarad capacitor. So mu means what? Micro. Micro का मतलब क्या होता है? 10 minus 6. Remember it always. Don't worry. Today you may be feeling कि सर ये तो numerical हो रहा है, थोड़ा boring लग रहा है. Don't worry. Tomorrow we will be having the theoretical sessions with complete videos, okay, and illustrations and animations. So this is 5 microfarad capacitor, and they say if the charge on the left plane of the 5, hold on, who is the student? Yeah. Charge on the left plane of the 5 microfarad capacitor. So 5 microfarad capacitor के charge on the left plane, the figure is 20 microcoulomb. So let us make it here as, write it here as 20 microcoulomb. If this is 20 microcoulomb, we need to check whether it will be plus or minus. We'll check afterwards. Okay. So they're asking then what will be the charge on the right plate of the 3 microfarad capacitor. So 3 microfarad capacitor is this, and this is left hand side, and this is right hand side. So now they're asking किस right hand side पे यहाँ पर, and this, what will be the charge ultimately? So this charge they're asking from us. ये value हमें ढूंढना है. Let me mark it as say Q1, small Q1. I'm marking it. Okay. So I need to draw the structure again, and just by drawing the structure, you will get the answer. Okay. So solution on your screen, maybe one more question, maybe we'll do. So the solution says this. This is a capacitor plate. This is the charge on this minus Q1 and positive Q1. And this is like this. Okay. This is also a capacitor plate. यहाँ पे charge है minus Q2 and positive Q2. So this is 4 microfarad capacitance. This is 3 microfarad. If you're having any doubt in the previous question, whichever is taught in today's class, no. So you can reply me. I've already given the number. Okay. So you can ask the doubts, whatever your doubts are, whatever material do you want, you can text here on the WhatsApp. Okay, good. So now these are the charges. Structure is already drawn. So here we were having one more capacitor which was having the capacitance as 5 microfarad capacitance. So they told कि अगर यहाँ पे minus 20 microcoulomb charge is provided, so what will be the charge here? So this will be the final distribution. Okay. So if this is minus 20, this will come out to be plus 20. And this here they say कि QCV करोगे अगर इसको, this is what? C, this is what? Q. So we know Q is equals to CV. So Q is here basically equals to 20 in magnitude, micro. C is in magnitude as 5 mu. Potential difference comes out to be 4 voltage here. कितना आया? 4 voltage. के 4 volt potential difference. मतलब ये हुआ कि यहाँ पे और यहाँ पे, yeah. Okay, 4 volt is the potential difference across it. 4 voltage, that's fine. Okay, and we don't know the charges here. Remember always, whenever you see this kind of case, when two capacitors are in a parallel condition, तो इसमें potential difference कुछ जो भी होगा, let me mark it as like V naught. Potential difference as V naught here. So in दोनों के across potential difference will be same V naught. So remember, when this is the case, you can just directly write like this as a trick. दोनों का ratio will be equals to capacitance का ratio. You know why I'm using this condition? Because we know Q1 is equals to C1, that is into the potential difference V naught, and then Q2 is equals to C2 into the potential difference, that is V naught same. Because both the capacitance are in parallel condition here. So when you'll find Q1 upon Q2, you'll get this as the answer. Okay. Now they're asking, we just need Q1 value. क्या कैसे करेंगे? So we have, let me take the next slide. We have basically Q1 upon Q2 as 3/4. ठीक है, तो क्या करना? Keep numerator as same. This is a mathematical approach here, star point. And add both of these at the down. So this will be Q1 plus Q2 because left hand side must match with the right hand side. Okay, that's fine. So this is what? 7. This comes out to be equals to how much? अब Q1 plus Q2 कितना है? If you see, what do you think? What it will come? What do you think, students? What it will come? So we need to find the charge. You're having the net charge ratio Q1 upon net Q as 3/7. ठीक है? So what you will do is this: to find the Q1 value, we'll use the complete rule that this 20 microcoulomb charge maybe will get distributed kind of, है ना? So we'll say 3/7 Q1 ये net charge है. This will go, this is basically 20 only. So net जब solve करोगे इसको, so this will come out something as what? 3 to the 6, 56. 8.5 microcoulomb as the Q1 charge. The charge, if there it is 20, here it will be 8 point something. 8.5 positive आएगा, positive or negative? Positive. Yeah. A is the answer to this. I hope you got it. What has been solved here? Okay. I hope you got this thing. So we'll see at the final very easy question at the end here. Yeah. This is one of the most easiest question ever been asked here. है ना? So बताओ इसका क्या होगा? देखो simple है. Anybody want to solve this? Last question. Then launch the poll. You have already solved in the previous YouTube videos. C parallel and C series. Based on these it is. See in the circuit shown, the energy stored in the 1 microfarad capacitor will be how much? इसमें energy stored will be how much? They're asking. With this, these two capacitors are in parallel. So the approach will be this. First, you will find C equivalent for this. Then this C equivalent and this is in series. इसके लिए फिर एक नया C equivalent. Then नए C equivalent plus this is in parallel. Then one more. So like this. Ultimately, the circuit can be resolved. The circuit can be resolved in this manner. Don't miss tomorrow's class. Otherwise, you will regret, because tomorrow's class will be with the pure. Today is just a practice session. Tomorrow is the main class. Okay, tomorrow, actually from tomorrow, I wanted to take the class. So that's why tomorrow we'll see the dielectrics. So the circuit ultimately can be resolved in some C equivalent dash, 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 and with the battery. So through this, you will get the net charge, and then that charge you have to distribute all over. This is the approach of this question. Okay. So I'm giving you this question as a homework, students. Take this question as a homework and try to solve it. Approach I've given you. ये दोनों series में, ये parallel में, get a C, then again C equivalent, then again parallel, get a C, then find the charge. Ultimately, when the circuit is resolved like this, find the charge. Once you get the charge, distribute this charge as per the energy conservation principle based on the parallel and the series combination of capacitors. Okay. So I am going to launch now PPT, this NPS poll. So the poll is in front of your screen. The time is less. We have 5 minutes left. After this, I'll be here. After the poll, if you are facing any doubt, can ask in the chat box. Okay. So participate here. Tomorrow the main class will start. Don't worry. Okay. So all the material will be provided to you in the description also, and whatever you demand will be included in tomorrow's session. So today we have seen a little bit of the numericals. Those students who have revised and come in the class were able to understand the numericals, and those who didn't revise the theory, maybe they were not able to understand, but no issues. Tomorrow there will be fresh, starting with dielectrics, plus this homework question as a numerical. This numerical as a homework question. Okay. Still, anybody want to study some other topic? Please reply me on the number. Again, I'm providing you here. You can text on the WhatsApp this number. Okay. Fine. All of you must participate here, and then I'm going to end this. If you're facing any doubt, can ask. We're having few minutes remaining, 2, 3. Yes, all of you must participate. Thank you so much for participation, students. Tomorrow the session will be as per the demand. Okay. Yes. Okay, I am ending the poll. So I've ended the poll, students. 2. Yes. So if you're having any doubt, if you're facing any doubt, can ask now, otherwise leave the session. Let me stop the recording also if it's required, because time is already up. Yeah, few minutes remaining. Any doubts? Yeah, so students, remember the topics from which we have completed today's numericals. Today's session numericals are this. That is, it starts with the formula C. I'm just writing in conclusion for few students who are here till now also in the session. Okay, C equals to QV and energy is half CV square. And for parallel plate capacitor, capacitance is given as A E naught by D. Okay, these are the different formulas. And remember that if two capacitors are in parallel, then what we do, how we find the C equivalent, we directly add them. These are some basic tips. And two capacitors are in series, we don't find the C equivalent just by adding them, as it was the case of resistance. What we do is this, we use this formula. Okay. So I hope students now it is cleared very much to you. If you're still facing any doubt, can ask. If you are facing doubt, student can ask. Yes. Tejaswani, Trishna, Yatish, Devgowda, or JNV Mandya, Bhuvna. If you are facing any doubts, students, please ask. I'm here for your doubts. Okay, so we'll continue with the 12th syllabus only. Okay. If any of the students is facing doubt in the 11th mechanics portion, you can reply me on the number. You can ask a specific doubt, no issues. Okay, bye bye everyone. Take care, study well. I'm ending this recording here. Yeah, recording is ended. And now it's time to end the session. Anybody having a doubt? Yes, Dev Goda, you are still in the session. Any doubt here? You can ask. Bhuvana, Yatish. Any doubt if you're having, you can ask. Okay. So remember the points tomorrow come with the revision. Let me write again here. Come with the revision of the theories till date what? Till date 30 June. So what are the capacitor theories is completed. So if you're thinking like this case from where the video, YouTube playlist. Okay. Or otherwise you can see the random videos from anywhere if you're having any course. But whatever, I just want to come prepared up to combinations of circuits, combination of parallel, combination of capacitors. Okay, so that we can start with the dielectrics. And don't forget to do homework question. For homework question, go for the YouTube and see what the question was. Okay, PDF will be uploaded on the same link. So this I'm writing here just for today. Got it? Okay. So I hope students now it's clear. Bye bye everyone.